Algebra 2. This is Unit 10, Lesson 4, and today we're going to talk about polynomial identities. So if we're looking at the do now at the top, I want to algebraically show that x squared minus 9 equals x minus 3 times x plus 3. So I just want to show that the left side equals the right side. So I can't really do much with the left side, but the right side, I can multiply that. So I'm going to FOIL that. X times x is x squared. X times 3 is 3x. Negative 3 times x is negative 3x, and negative 3 times 3 is negative 9. I get 4 terms, and remember those two middle terms can be combined together. They actually cancel each other out, and I just have x squared minus 9, which matches what I have on the left. Okay, so these polynomials really just consist of basic operations. So I can use the associative property, the commutative property, the distributive properties. You've done this many times before, and basically I'm just going to use those properties to get the left side to equal the right side. So notice the name of this, polynomial identities. They're identical to each other, so the left side and the right side are matching. So an identity is an equation that is true for all values of the replacement variable or variables. This is sort of like a proof in Algebra 2. So it might say prove, it might say show that. And basically all you're doing is you want the left side and the right side to be matching. So you're going to work on one side of the equation at a time. You're not going to move things from one side to the other side. Whatever on the left stays on the left, whatever on the right stays on the right, but you're going to be using distributive and commutative and associative to move things around so that the sides are matching. So one identity that you're probably already familiar with is exercise 1. X squared minus y squared equals x minus y times x plus y. And this is exactly like the do now, but the do now had some numbers in it, and this one does not. So I'm going to leave the left side alone, and the right side I'm going to use that distributive property. So x times x is x squared, x times y is xy, negative y times x is negative xy. And could I write that as yx? Absolutely, that's the same thing. And negative y times y is negative y squared. Just like above, in the do now, I get 4 terms, and these two middle terms I can combine together. They actually cancel each other out, and I am left with x squared minus y squared, which is exactly what I had on the left. All right, so basically you're proving these identities by just manipulating one side of the equation. Actually, you might have to do both sides, but in this particular case, the left side, nothing to do with it. The right side, I was just going to FOIL it. All right, so in this one, exercise 1, I want to show algebraically that the identity is true. I'm going to have to do some multiplying to both the left and the right. So on the left, I have x squared plus y squared squared. So that means I'm multiplying that by itself. And on the right, I have x squared minus y squared squared. So again, I'm multiplying that by itself. And I also have 2xy squared. So I'm multiplying that by itself. That won't be too bad, though, that part. All right, so there's a lot of multiplying, a lot to keep track of. X squared times x squared is x to the 4th. X squared times y squared is x squared y squared. Oops. And y squared times x squared is x squared y squared. I'm just going to write it in the same order as the other one so I recognize that I can combine those together. And y squared times y squared is y to the 4th. So I get 4 terms, but those two middle terms I can combine together. X squared y squared plus x squared y squared is 2x squared y squared. Whoops, and this I made a mistake on. This was x to the 4th. I don't know why I wrote x squared. All right, so I simplified or multiplied out what was on the left. Now let's do the same thing on the right. So maybe I'll get another color just so you can see what I'm multiplying. X squared times x squared is x to the 4th. X squared times negative y squared is negative x squared y squared. Negative y squared times x squared is again negative x squared y squared. And negative y squared times negative y squared is positive y to the 4th. And those two middle terms I can combine together. And this last one, 2 times 2 is 4. And when I'm multiplying, I add exponents together. All right, so now, actually, these are all similar terms. This one, and this one are all x squared, y squareds. So those can all be combined together. -1 and -1 is -2, and -2 plus 4 is 2x squared, y squared. So everything that was in yellow, I just combined together, and it was 2x squared, y squared. So I did it. Left side looks exactly like the right side. That's all I'm doing on these. So a lot of multiplying and manipulating the equations. Show that a plus b squared minus a minus b squared equals 4ab is a polynomial identity. You wouldn't think that it was, because the left side is pretty complicated. The right side is just 4ab. But let's see what happens. A plus b squared is really a plus b times a plus b. And then a minus b squared is a times b times, a minus b times a minus b. All right, but I am subtracting that whole thing, so don't forget that. I'm subtracting everything, so I put that all in parentheses. So let's see what we got. These two right here are a squared plus 2ab plus b squared. All right, I FOILed it out. And I also combine those two middle terms at the same time. All right, now I'm going to FOIL these. So that gives me a squared minus 2ab plus b squared. All right, I FOILed it. A times a is a squared. A times negative b is negative ab. And negative b times a is negative ab. So I really have negative 2ab. And negative b times negative b is positive b squared. All right, and the right is just perfect. I'm leaving that alone. So a squared minus a squared, well, those cancel. 2ab minus 2 minus negative 2ab. So this negative sign is being distributed to everything inside. 2ab minus negative 2ab is 4ab. And b squared minus b squared, the b's also cancel out. Okay, so we did it. You proved that that was a polynomial identity. All right, let's just do this last one, number 3. All right, the next page just has some more to try. But right side is looking pretty simplified, nothing to do, nothing to multiply. Left side, I have a plus b times a plus b. Okay, because I have a plus b squared. I'm multiplying it by itself. The right, I'm going to leave alone. So now the left, I'm just going to FOIL that. A times a squared. A times b is ab. B times a is ab. All right, I'm going to write it matching in the same order. B times b is b squared. I always get 4 terms, but those two middle terms I can combine together. 1ab plus 1ab is 2ab. And I did it. I got the left side to equal the right side. Okay, so that's all we're doing on these identities. We're multiplying and combining things together to make the sides match and be identical to each other. So we'll practice that tomorrow.